Hey everyone, another homework problem from 8.1, Basics of Hypothesis Testing. Previous video we looked at using the p-value method. On this one we will look at using the critical value method. So the test statistic of z equals a negative 1.94 is obtained when testing the claim that p equals 1/4. Using a significance level of 0.01, find the critical values. So I'm just going to combine the first three steps of the hypothesis test, steps 1, 2, and 3. First, I claim the ID claim is p equals 1/4, and then I'm going to write what doesn't this contain? P equals 1/4. I'm going to write it in symbolic form. Well, it contains everything that is not or not equal to 1/4. So now I'm going to write out my hypothesis. My null hypothesis is simply p equals 1/4. My alternate hypothesis then is going to be p is not equal to 1/4. Again, your alternate hypothesis does not contain equality. And what this turns around and tells me, my alternate, is what kind of test. This is a two-tailed test. Whenever you have not equal sign, it's two-tailed. Step 4, that's steps 1, 2, and 3. Step 4 deals with significance. My significance level was 0.01. And step 5 deals with identifying the test statistic, and that was given to us, z equals a negative 1.94. So step 6 is where we go different with this. Critical value method. Again, that's in your flow chart of your steps for how to do your hypothesis testing. And I like to visualize what I'm looking at. So something like that. I know my penmanship isn't the best. And even though this is supposed to be symmetric, what I'm actually looking for is this. And this will be a negative z, and this will be a positive z, right? To the left of z equals 0 is negative, to the right is positive. And these are my critical values. These are my critical values. That's where the significance is inside of here. In statistics, that's what we're looking for. We want to know that significance. So alpha represents the area under the curves here and here. That's what alpha represents. Alpha represents that shaded area, and we know that alpha is 0.01. Then what do we know for each one? We'll divide it in two. There's two tails that we're looking at. So this one is 0.05, or 0.05, sorry. I need to make sure I use my calculator on that. I always mess that up. That's a mental block for me. 0.01 divided by 2. Yep, 0.05. And this one represents 0.005. There's symmetry under the curve, so all I need to do is look up one of those. I can choose to look up 0.005, or I can choose to look up the 0.9950. But instead of just doing the math, I'm going to look this up. I'm going to get a negative z-score from this for what I look up. So 0.005, get out my chart, and you can use the little table down at the bottom also. And what I'm looking up is not the z-score. Apologies, that's what I'm trying to find. This is the probability, the area under the curve. So 0.005, and on your table there's that asterisk, and it takes you down, and I find the z-score of 2.575. So a negative 2.575, and most often what they're going to tell you to do is to round to 2 decimal places with your z-score. So I know, and there's symmetry, so I know my positive z-score is just a positive number. These are my critical values. Lead is messing up my pencil. These are my 2 critical values. So let's see, I'll draw that out for you. I think it's better to visualize it. So I have my curve. Wish I could draw those better. And I'll just make them like this. And there's symmetry. This is a negative 2 point, and I'll go ahead and round it off. Let's say 5.8, a negative 2.58, and this is a positive 2.58. And then what I'm looking at is, where does my z-score that they gave me, a negative 1.94, well, that would be somewhere, let's just say here. I know it's to the right of this and to the left of this, so this here would be 0. A negative 1.94. That's the z-value that I've been given. So with our critical value method, is that how, let's say, if the test statistic that we have, and that is this, if the test statistic is say the critical region, then reject H0, then reject H0. If not, then fail to reject H0. So my value isn't in those critical areas, the significant areas, right? It's in between the two. So it doesn't reach there. So for my particular problem, what I'm going to do is that I am going to fail to reject. You can think of it, it's not significant enough. I'm going to fail to reject the null hypothesis. That doesn't mean that the alternate hypothesis is correct. It does not mean that it is not equal to 1/4. I am just saying I reject that. I don't know what it actually is. It just simply means I need fail to reject that. And upon gathering more data, it may turn around and end up being true. But for what I was looking at for that, I need to fail to reject. And that is the hypothesis testing using the critical value method. So I ask that you watch the publisher's videos, critically think and structure your homework, follow that flow chart, work everything through, and good luck on your homework.